Greetings everyone. Today we're going to explore graphing quadratics, specifically in standard form. We do have a foldable for this and you'll definitely want it just to stay organized as we've got a lot to go through. So far this year, just a quick review, we've graphed lines in two different forms. We quickly went over y equals mx plus b, and then we spent time in translated form where we talked about the shift of a point. Oops, K and H, there we go. We talked about graphing linear inequalities, so where do we shade? Is it dashed or solid? And then more specifically, what we're going to relate to a lot today is graphing absolute value functions. All of the traits and descriptions we used for graphing absolute, we're also going to use for graphing quadratics. The difference today is we don't have a constant change, right? In an absolute value, it was kind of like a slope, but today is a curve. It's going to be a U shape, which means the change isn't constant. As always, we need to first and foremost make sure that our equation is written standard form. If you're missing an A, B, or C value, you can always recognize it as a 0. And remember, f of x is the same as saying y. All right, the first thing we're going to do in our notes is talk about the parent function, meaning before we have any changes, shifts, we want to just look at where every graph comes from. So we still want to pick that middle value. We're going to use the typical 5 values that we've been using since we were in Algebra 1. So we're going to go from 2 to -2. Let's plug those values into the parent function. 2 squared, 1 squared, 0 squared, -1 squared, -2 squared. This, let's label it, is our parent table. We are going to use this parent table in a future lesson. It is something you need to either memorize or create each time. Let's talk about the domain. The domain is similar to absolute value in that we're going to go forever left, forever right. Because when we graph our points, we're going to have a U shape. And a U shape, even though slowly, goes forever left and forever right. Our range is also going to look like the absolute value functions. We exist from 0 to infinity on the parent function. Now remember, 0 is included, so we're always going to have a bracket in our range for a quadratic. Let's answer a few more questions about the parent graph. All parabolas or quadratics will be continuous. In this case, because our graph crosses the y-axis, that's my axis of symmetry, it is even. It reflects in the y-axis. Now, a parabola will never be odd. It will never have that 180-degree rotation around the origin, but it could be neither. Typically our graph is going to be neither. Maximum or minimum are also called extrema. Because we have a U shape, you're always going to have one or the other. So I have no maximum, right? Because it goes forever. But I do have an absolute minimum, and that absolute minimum is my vertex, which in this case is 0, 0. And that's what I'm looking for. When I ask for extrema, I want to know, is it an absolute min or max, and where? Intervals of increasing. So I am increasing from the 0 x value to the infinity x value. I'm decreasing from the -infinity to 0. All right, so remember when we're looking at that, we're really tracing it left to right. If I start tracing, I'm decreasing, 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 and we go x value to x value. And then from the x value, I'm increasing, increasing, increasing. Okay, so make sure we use our x values. End behavior. Some of this might be filled in for you. What we're looking at is when x approaches infinity, meaning as my graph goes to the right, then my y value, or f of x, they mean the same thing, is also approaching an infinity. That means as I go right, I'm going up. Let's look at the other side. As x approaches negative infinity, as my graph goes left, it also goes up. Right? Look at that. I'm going up, I'm going up. So an assumption you can make with a parabola, it's always going to positive infinity, or it's always going to negative infinity. They're both going to go the same direction. All right, let's talk about intercepts. Now in this particular graph, because I'm at the origin, I have 0, 0, and 0, 0. But one thing you need to consider, x-intercepts occur on the x-axis, meaning they exist if I plug in 0 for y. I can plug 0 in for y on any function and solve, and we're going to do a lot of this. This is where your work is going to exist. To find the y-intercept, you plug 0 in for x and find your y value. That's going to be a little bit easier on this one, so you might not need to show a lot of work. Again, just like v-graphs or absolute value graphs, each parabola has two sides, right? We've got a vertex where I change direction. I can cross at the x-axis at most 2 times because I can have at most 2 real solutions. All right, so we want to see that symmetry around the axis of symmetry when we graph these. All right, a couple of notes we're going to fill in on our foldable. One of the easy vocab words we're going to work with is concavity. You'll remember this from geometry class. If I ask you what the concavity is, we have an option of saying concave up. That's when it's opening upwards. And we have the option of concave down. So it's very straightforward. Up, opening up, down, opening down. The vertex. So typically when I create my table of -2 through 2, if I'm dealing with standard form, very specific, I don't always want to start at 0, right? I want to start at the middle. I want the middle to be the middle. So to find the x value, the middle x value, we're going to use -b over 2a. That helps me find the x value of my vertex. That looks familiar, right? You don't need to write this down, but think of the quadratic formula again. If I write down the quadratic formula, the middle comes from the non-radical piece, right? That creates the middle. The plus or minus is just telling me how far left and right I go from the vertex. So it makes sense. We're pulling that from the quadratic formula. Now, if I find the x value of the vertex, I can find the y value of the vertex by plugging in, now this is going to be pretty generic, not very mathematically written, but by plugging in the x value into the function, right? If I plug in the x, I'll find the y. I can plug in any x I want in the whole world to find the y values. So let's take this information and let's apply it to a quadratic in standard form. So you have this foldable. We're going to start off with the middle. And again, for some reason, we might have had extras on your handout. If we did, we only need 5 spaces. So cross off extras if there are. We want to start off by finding our middle value. Where should my middle value be? To find that, we are going to use -b over 2a. Opposite b, instead of -4, +4, over 2 times a. 4 divided by 2 is 2. You need to find that middle value, and then you're going to pick the integers on either side. All right, I found my x's. Now, because this is in standard form, to find your y's, you are going to plug in those x values into the function and solve. Right? If it says x, plug it in for x. I'm going to show a little bit of work. So for example, 4 squared minus 4 times 4 minus 5. Show as much or as little work as you need. It is a lot of calculator work. 16 minus 16, 0, minus 5, -5. Let's plug in 3. 3 squared, 9, minus 4 times 3, 12, so I'm at -3, minus 5, -8. 2. 2 squared is 4, minus 4 times 2 is 8. 4 minus 8 is -4, minus 5, negative 9. Plug in 1. 1 squared minus 4 times 1 minus 5. 0. Oh, that's easy. 0 squared minus 0 minus 5, negative 5. Let's plot our points. Now I see the symmetry in my numbers. If you don't see symmetry, go back to that middle value. Did something go wrong? Do I have a miscalculation? I might need to do a little bit of investigating and fixing. So if I plot my points here, I should see the symmetry. Now, I don't know my x-axis values yet, so I'm only going to graph so far. I'll have to finish the rest later when I get more information. In this case, this one is concave up because it's opening upwards. All right, let's answer some more information. The vertex is my middle point, which was 2, negative 9. We're going to use that a lot. The extrema, you'll be asked for that, is a minimum at 2, negative 9, at the vertex, right? Axis of symmetry, meaning what is the line that I'm reflected around, and that line is x equals 2. It'll always be x equals whatever number your x is. So you don't even need a graph for that. End behavior. As x approaches infinity, my y value is approaching infinity. As I go right, I go up. As I go left, I'm going up. If it's concave up, they're both positive infinities. This graph is for sure continuous. Hey, let's bring back boundedness from a previous lesson. This one is bounded below, meaning there's a below wall, invisible wall that I'm not crossing. Let's jump to domain and range. That's pretty basic. We've been working on that for quite a while. Forever left, forever right. I go as low as negative 9 and up to infinity for my range. Increasing, decreasing. On these, please make sure to label if it's not labeled for you, okay? So I am increasing from the x value of 2 to forever. I am decreasing from the x value of negative infinity to 2. With parabolas, you will always have one of each of those. So again, if I look at my graph, follow along. Decreasing, 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 increasing, increasing, increasing. If you need to draw arrows just to help yourself out, please do so. Now, the next 2 boxes, I skipped those because that is where I need to see some work. Maybe jot a few notes down here. We are solving here. This is why we had so much solving in the last unit. To find the y-intercept, if I want to know y, I plug 0 in for x. If I want to know x, I plug 0 in for y. Right? Think of what you know of what an intercept means. Okay, well, if I plug in 0 for x, actually, I'm going to replace f of x. Let's just say y. That's easier, right? Y equals 0 squared minus 4 times 0 minus 5. 0, 0, negative 5. Don't leave it like that. This is a point. My y-intercept is 0, negative 5. And let's go to our graph. We see that. It makes sense, right? Let's do some work for solving for x. Now, here's where we have to be careful. Your work, you have so many options. You can first try to factor and solve. You can do quad formula and solve. You can do completing the square and solve. And not today, but in the future, you could also solve by square roots. If you need help with any of these, you need to see a previous video, okay? I'm going to try factoring first, okay? Because this looks nice and pretty and clean. So let's take our function. I'm going to plug 0 in for y, and I'm going to try to factor this. 0 equals, let's set up our parentheses. Factors of x are x and x. Factors of 5, 5 and 1. Negative, positive, it works. If I set each piece equal to 0, I solve. I got negative 1 and 5. Now, please don't leave them that way, right? Because this is a graphing unit. They're not just numbers. They are values on a graph. I have the x-intercept of 5, 0 and negative 1, 0. Now we can go finish our graph. Go plot a dot at 5, 0 and at negative 1, 0 and connect them. Okay, so if we look, this makes sense, right? It makes sense with the rest of my graph. If you do all the work and the numbers don't make sense, that's your moment of self-reflection to say, hey, I need to maybe resolve and start fresh. Now, that one factored nicely, and I know this isn't on your notes sheet. Maybe jot it down in your notebook. But I wanted to talk about what does it mean when it's not a perfect factorable quadratic. Okay, so I'm going to separate this into two thoughts. I'm going to find my y-intercepts again, and I'm going to find my x-intercepts again. So for a y-intercept, if I want to know y, I plug 0 in for x. So I've got y equals, because remember this is the same as y, right? You got to know that. I've got 0 squared plus 4 times 0 minus 7. Standard form is nice and easy. You've got 0, comma, negative 7. Okay? I don't think you need to show work on those, but I do want to see it written as a point. Let's do some more work for the x-intercept. If I want the x-intercept, that means what is x when y is 0? So I'm going to replace y with 0. Now it looks like our solving quadratics unit. This is not factorable. There are no factors of 7 that will combine to get 4. So I'm left with completing the square or quadratic formula. I'm going to show both. Okay, if you want to fast forward or skip one or the other, please do so. I'm going to start with quad formula. The quadratic formula is opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. If you need to show more or less work at this point, that is up to you. Okay, meaning maybe you can find the entire discriminant but with mental math. 4 squared is 16, right? Negative 4 times 1 times 7 is positive 28. If I simplify that, I've got 38, 44 all over 2. Let's go again. 44 breaks down into 4 and 11, which is 2 radical 11 all over 2. Let's go again, okay? Every term, again, go back to my quadratic formula video if needed, but they're all divisible by 2. So I arrive at negative 2 plus or minus square root of 11. These are x-intercepts. Let's write them as a point. Negative 2 plus or minus the square root of 11, comma, 0. Now, I'm okay if you leave it as plus minus or write it as two separate values. But let's talk about that for a second. If you plug that in your calculator, please try it, okay? Square root of 11 is 3 point ... It's a crazy 3 decimal. So if I was to estimate, negative 2 plus 3 something is 1 point something something something, comma 0. And negative 2 minus 3 point something 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 is negative 5 point whatever it is. Okay, I'm totally rounding. So graphically on this one, you can still check your answer, right? If I plot 1 in a little bit and I plot negative 5 in a little bit, it needs to make sense. Okay, if you want to see completing the square, I'm going to do that next. If you don't want to see that, then please fast forward. All right, completing the square, it's in standard form. We're going to kick the 7 to the other side. To complete the square, I'm going to take 4, divide by 2, square it. 2 squared is 4. I'm going to add 4 to both sides. I now have a value squared and 11 on the other side. That factors to x plus 2, x plus 2. See my previous video if you need more help. I'm going to square root both sides. X plus 2 equals positive and negative 11. I'm going to subtract 2. Negative 2 plus or minus square root of 11. You guys, that was actually faster than quadratic formula. So pick a way that you like, stick to it. If you want to become well-versed, jump between the two solving options. But no, you're going to have crazy x-intercept work. I want to see it every time. Even if it's imaginary, even if you have negatives under the radical, even if it doesn't simplify, I want to see all the work. So that was kind of a lot. This is a new topic. If you need more examples or more help, please see me. Let me know what questions you have. Check out the Sabre Center for additional support. Check out Google Classroom for what your task is today. And until next time, have a good one.